In this video lesson, we're going to talk about polygon angles. So we're going to start off again with a little bit of vocabulary. There we go. The first thing that we're going to talk about is a regular polygon. A regular polygon is a polygon that is equilateral. That means that it has equal sides, and equiangular. That means that it has equal angles. So a regular polygon has to be both equilateral and equiangular. A concave polygon is a polygon in which at least one line segment that connects any 2 points inside the polygon does not lie completely inside the polygon. A convex polygon is a polygon in which every line segment connecting any 2 points inside the polygon lies completely inside the polygon. And those are very wordy definitions that I will give you examples for here in a second. The interior angle of a polygon is any of the angles inside a polygon. An interior angle forms a linear pair, and remember, a linear pair is two adjacent angles that are supplementary, which means they add up to 180 degrees, with an exterior angle. Polygon is a closed figure formed by 3 or more line segments in a plane such that each line segment intersects exactly 2 other line segments at their endpoints only. So here are 2 examples of a polygon. Okay, this is the vertex, right, where any of our 2 points meet. So these all would be vertex, okay, vertices right here. The sides and the edges are all of these right here. So again, for this one, the sides and the edges are any of the lines, okay, and then the vertex would be any point where the 2 lines are meeting. A concave polygon, remember we said a concave polygon means that a line segment that connects any 2 points does not lie completely within the polygon. So if we made 2 points, this line segment does lie within the polygon. But what if I made these 2 points right here? Now those 2, when I connect them, see how that line comes outside the polygon? That means it's concave. Now with this one, it doesn't matter where I put any dots. No matter where those dots are at, those lines are going to always be inside that polygon. Now, I really don't have to do this. Usually, if you just look at it, concave, think about something caving in. Usually, that polygon is going to have a caved-in edge. And a convex polygon is not going to have that concaved edge. Sum of the interior angles of a polygon. Now, we already talked about triangle sum theorem in the last lesson, and we know that a triangle adds up to 180 degrees. Now we're going to talk about the sum of the interior angles of other polygons that are not triangles. If we don't know, if we don't have a triangle, then we're going to use this formula. Okay, it's S equals 180 degrees times n minus 2, and n equals the number of sides that the polygon has. So for example, if we want to find the sum of the angles of an octagon has 8 sides. So what we will do is say that S equals 180 times 8 minus 2. So then we'll say S equals 180 times 6, which equals 1080. So we know that an octagon, all of the interior angles add up to 1080 degrees. For a decagon, that would be 10 sides. So we're going to say S equals 180 times 10 minus 2. So S equals 180 times 8, which equals 1,440 degrees. So a decagon has to add up to be 1,440 degrees. What if we're given the number of degrees and we want to know what the polygon is? So here we know that the sum of the angles is 900 degrees and we want to know what the polygon is. So what we're trying to find now is n. We're given S. So now instead of plugging in n, we're going to plug in s. We're going to say 900 equals 180 times n minus 2. And here's where your algebra comes back into play, right? Remember, we're going to distribute 180. So this is 180n minus 360. So now we're just going to solve this out. All right, we're going to add 360, which that's going to give me 1260 equals 180n. And then I'm going to divide 1260 by 180. So n equals 7. So that would be a heptagon. For this one, we want to find the degree of angle x. So we're given all of the sides except for this one. So the first thing that we need to know is what should all of these angles add up to? So we're going to count our sides. 1, 2, 3, 4, 5, 6. So we have a hexagon, 6 sides. So we're going to use our formula, 180 times 6 minus 2. So we have 180, and we're going to multiply that times 4. And that's going to give us 720. So we want all of these sides to equal 720. So for this one, we're going to add up 106 plus 119 plus 109 plus 115 plus 138. And that equals 587. Okay, so we know that all of these add up to equal 587. We know that this whole polygon has to equal 720. So now we're just going to take 720 minus 587. And that is going to give us 133. So we know that x equals 133 degrees. Now, if we're given just regular polygon here, okay, remember a regular polygon means that it's equilateral, so it has equal sides, and then it's equiangular. It has all equal angles. So we know that all the angles are equal, all the sides are equal. So on this one, how many sides? 1, 2, 3, 4, 5 sides. Okay, so we have 5 sides. So now we're going to find the sum of the interior angles. So we would say 180 times 5 minus 2, okay, so that equals 180 times 3, which equals 540. Okay, so if we know that the sum of the interior angles is 540, and we know this is a regular polygon, so we know that all of our angles are equal, then all we have to do is take 540 and divide that by 5 to find the measure of one angle. So we know that one angle is going to equal 108 degrees. And that is it for polygons.